Hello, statistics students. This is going to be our next lesson to go along with the next worksheet. By the way, I have figured out Kidem a little bit better and how to upload items on your phone and on the computer. I have to make a Dropbox. So I didn't do that for the last assignment, but I actually updated it so you're able to Dropbox some of these files. So you have this next assignment that's going to be due at this lesson. It's the 4.1 part 2, other sampling techniques. Very short, just like this lesson is going to be pretty short, but we're looking at the other ways that we can sample. So last lesson we talked about taking a simple random sample, and you got to practice that on the last worksheet. So simple random samples are fine, but sometimes they can get a little tedious. For instance, if we took the entire 2,000 students at our school, let's include the distance learners, and let's say I wanted to survey them, how difficult would that be to survey both distance learners? Like, let's say I randomly select a student who happens to be a distance learner, and then another student that I select is somebody that's in school, and then you got to go collect data on them. It gets very messy very quickly. So sometimes it is actually a lot of work. Simple random sampling is the best sampling technique, has the least amount of bias. That was something that we wrote down was bias. I believe we defined that right here, bias, in the last lesson. So we don't want any bias in our sample, so random sampling is the way to go. But we're going to talk about two other sampling types. So the first one that we're going to talk about is called a stratified random sample. So I have definitions here that I need you to put into your notebook, and if you would, starting off your notes, draw a line and make the title, let's see what I want to call it, and I'll pause the video to put in this title. This is going to be, draw a line, say other sampling techniques. I'll pause and tell you to do that. Okay, so let's go ahead and write down these two definitions. Start with the word strata, okay? Because the method is called stratified random sampling. So you can write that on top. Stratified random sampling. Strata is like a group, okay? So it's just the statistical name for it. So strata, you classify the population into groups of similar individuals. So this could be same ethnicity, same gender would be a strata, same grade. You can come up with anything that you have a group of people who are alike and you group them that way. Okay, so that's strata, classify the population into groups of similar individuals. Okay, so make sure you're writing that down. You can pause the video to get that. Then write stratified random sample, which the blue definition is what that is. So it says choose a separate SRS. So take a simple random sample in each stratum. Stratum is singular for strata. Strata is plural. So let's say I broke the school into freshmen, sophomores, juniors, and seniors. I'm going to take from each group a random sample, okay, and combine these SRSs to form the sample. That's the idea. Now I've got a video that I'm going to put in here just in a second, and it'll explain this a little bit more. I actually had another PowerPoint. This is the one I want. Okay, advantages of stratified sample. Okay, not as time consuming as an SRS, and then there's also statistical advantages when comparing stratum. If I want to see if there's a large discrepancy between the GPAs of honor students versus non-honor students, that would be something I'd want to do. I'd want to go ahead and separate those students, and stratum would allow us to do that. Okay, it gets the real thing is this: statistical advantages for stratified random sample is you have representation. Okay, from all groups. So let's say we did our school and we want to break it down by ethnicity. We want to get the opinion of everybody on the distance learning platform, whatever. So if I broke this down, or if I just gave a random sample, the majority of my sample would be the majority ethnicity. okay? I may not even get a minority that has a very small percent at our school. So if I went ahead and broke everything into strata, okay, we have every ethnicity in their own group, and then I take random samples from all those, everybody's represented, okay? That's the main statistical advantage for this, is representation from all groups in the population. Disadvantages, the samples usually are not as, I don't want to say diverse, but let's actually change. The samples are not, the samples do not model the population as well as a true random sample. This will lead to a small amount of bias compared to an SRS. So that's, I just needed to change that. So since we're getting representation from all these groups, say I sample 20 people and I'm going with the ethnicities. Let's say that 60% of our school is Caucasian, 30% African American, and then just decreasing from there through the other minorities. So if I take a random sample, my sample should look like that group. It'll look like the population. But if I'm doing a stratified sample, I have almost equal representation from every group, which doesn't really model the population, so it's a little bit more biased. So you have to decide when you're doing a sample if that's what you want, okay? And then it can still be difficult to track individuals down because you're breaking them into groups and you have to move around, okay? So that's the disadvantages and advantages of stratified samples. Next, cluster samples. So this one is the cheapest and the quickest, but still technically is a random sample. Okay, so let's write down definitions. Start with the yellow one. The first definition is clusters. So write down clusters. Clusters, you're classifying the population into groups of individuals that are located near each other. Okay, that's the only determination of a cluster, is they're next to each other. Okay, so you know where everyone is, so it's easy to go and get their information. So they're broken into these clusters. Once you break them into clusters, we have the next definition, cluster sample. So they're in clusters. The cluster sample, you choose an SRS of those clusters. All individuals in the chosen cluster are sampled. Okay, so think about our school. And this is kind of difficult because we want these clusters to look like the population, and the video that I'm about to show will explain this hopefully better because it has visuals and such. But we want these clusters to look like our population. Let's say I had 20 clusters, and let's just say that's 20 classrooms. Okay, what I'm doing then is I'm numbering the clusters, an SRS of those clusters, and I'm going to randomly pick them. Okay, through a table or the technology, like the last homework assignment you had. Okay, so that's the idea of cluster sample, and you just go and you survey everybody. In a stratified sample, we broke them into groups that were alike, one characteristic made them similar, and then we randomly sampled within those groups. That's not how cluster works. You break them into groups, and everybody in that group that you pick randomly gets surveyed. Okay, so this way is not as time consuming as SRS or stratified sample. It is the fastest version. Okay, and then you do have, and ideally, if your clusters are chosen properly, the advantage is it's going to look like small versions of the population, which was the issue of stratified sampling, is that it wasn't really looking exactly like the population. Okay, so again, the samples in these clusters still won't be as diverse as a true random sample, so it will lead to some bias. Okay, so I'm gonna pause. There's a video that's embedded in here. It's only like 6 minutes long. Let me check. No, it's 3.5 minutes. Perfect. Okay, and this guy's gonna explain random, stratified, and cluster. He's gonna go through all the ones we've studied, and then he adds another one called systematic, which isn't really gonna be assessed for us, but you can check that one out too, systematic. But a really good video. I just didn't have time to make one explaining, so I liked what he did. So I'm going to pause and let you watch that video. Okay, so you've checked out the video. Now what I want you to do is we're going to look at this question here, and you're going to give me a free response. A, B, and C here need to be answered, and you're going to construct a response on how this would work. So it says, describe how you would use the following sample methods to select 80 students to complete a survey. So here we have an auditorium, okay? And this actually comes from the book, so let me make sure that, okay, here, I'm gonna show this. Okay, I'll use this. So there are 800 students present at the assembly. So imagine this is in our theater at school. A map of the auditorium is shown on this page here. Note that the students are seated by grade level and that the seats are numbered from 1 to 800. So this picture is actually a lot better. Let me zoom in. This sort of shows what is happening. And you notice that it's sort of continuing infinite from the front row 1 to 20 all the way down to 781 to 800. All right, so your task is to figure out how would you conduct a simple random sample, describe that for me. How would you conduct a stratified random sample, and then how would you construct a cluster sample, okay? And so that's what all I want you to do is create the idea. Imagine yourself doing that. On your worksheet, you're actually answering the advantages for all of these and the disadvantages for all of these based on this question that you're doing, okay? So I'm gonna pull this back up, take your time, and construct response for all of these, okay? All right, I'll be interested to look at your feedback or to look at that. And I might make another video and send that out on email of the solution that I would come up with for this. But for now, since I'm sort of short on time, I'm going to go ahead and stop the video there. If you have questions, email me or send me a remind. Email is usually better because remind, sometimes I'll look at them and they get lost and I forget. So emails are definitely really good. Okay.